Aditya-L1 is India's first space-based solar observatory mission, which was successfully launched on Saturday, September 2, 2023 superscript 1. It aims to study the Sun's corona, chromosphere, and photosphere, along with the particle flux emanating from the Sun and the variation of magnetic field strength squared. Aditya-L1 will travel about 1.5 million km from Earth to a point in space called Lagrange Point 1, L1, where the gravitational forces of the Earth and the Sun are balanced. This will allow the spacecraft to have an uninterrupted view of the Sun throughout the year cubed. Aditya-L1 carries 7 payloads and instruments that will observe various aspects of the Sun using different wavelengths and techniques. Some of these are: Visible Emission Line Coronagraph, VELC. This will create an artificial eclipse of the Sun and capture images and spectra of the Sun's corona, which is the outermost layer of its atmosphere. It will also measure the magnetic field of the corona using a polarimeter 4. Solar Ultraviolet Imaging Telescope, SUT. This will take images of the Sun's photosphere and chromosphere, which are the inner layers of its atmosphere, using narrow and broadband filters in the ultraviolet range. It will also monitor the solar irradiance, which is the amount of energy emitted by the Sun. 4. Solar Low Energy X-ray Spectrometer, SELEX, and High Energy L1 Orbiting X-ray Spectrometer, HEL1-OS. These will measure the intensity and spectrum of the soft and hard X-rays emitted by the Sun, which are indicators of solar flares and other energetic events. They will operate in a Sun as A-star mode, meaning they will observe the whole disk of the Sun as a single source. 4. Aditya Solar Wind Particle Experiment, ASPEX. This will analyze the solar wind, which is a stream of charged particles that flows from the Sun. It will measure the density, velocity, temperature, and composition of protons and heavier ions in the solar wind, as well as their direction. 4. Advanced Triaxial High-Resolution Digital Magnetometers. This will measure the in situ magnetic field at L1, which is influenced by both the Sun and the Earth. It will provide data on how the magnetic field changes over time and space. 4. The Aditya-L1 mission is expected to last for at least 5 years and provide valuable data for understanding the Sun and its impact on Earth. It will also help in improving our ability to forecast space weather, which can affect communication systems, satellites, power grids, and human health squared. The mission is a tribute to U.R. Rao, a former chairman of ISRO and a pioneer of Indian space science squared.